in the future. So, for example, when SpaceX launched the Dragon capsule to the space station for the first time, it worked. It worked perfectly. They're great engineers, but the reason it worked fantastic is they had a highly accurate computer model of the entire system. And so they modeled it in high fidelity, and it performed like the model said. And so, for example, more recently, we see Starship making serial advances as it's going towards orbit. Of course, you know, the Crisis News Network and all the media say, "Oh, Starship fails." It's like bullshit. It was an amazing incremental success. You know, the first ship got to a certain point, the second ship got further, the third one will probably work perfectly because those ships are highly instrumented and all the data is coming back, and the data is being used to advance the models and saying, aha, this is actually what was going on. And so let's change this engine or this structural entity. And we're going to start to do the same thing in biology, which we're going to start to gather enough data and instrument and understand what's going on, where we can eventually get to a point where we have a highly accurate model of the human cell. And not just a cell, but maybe it's an organ, maybe it's a 1,000 cells or 1 billion cells. And we're going to know that this particular designed protein or medicine, whatever it might be, works perfectly. And we'll get to a point where you don't need to go through a massive clinical trial. How far is that away? It's probably not the next 5 or 10 years, but it is probably 20 to 30 years out. But the cost of these, right? And